Why do quadratic roots appear as x-intercepts? Imagine drawing a curve on a graph and seeing where it touches or crosses the horizontal line called the x-axis. Those points are where the quadratic roots show up as x-intercepts. When you work with a quadratic function, which is written as f of x equals a x squared plus bx plus c, the roots are the x values that make the function equal to 0. Think of it like solving a puzzle. You want to find the exact x values where the graph hits the x-axis. These points are called x-intercepts because they are where the parabola, the U-shaped curve, crosses the x-axis. Now, why do these roots match the x-intercepts? Well, because at those points, the output of the quadratic function is 0. When you plug in the root into the function, the output becomes 0, meaning the graph touches or crosses the x-axis. The roots are the solutions to the quadratic equation when set equal to 0. The quadratic formula, which is x equals negative b plus or minus the square root of b squared minus for a c, all divided by 2a, helps find these roots exactly. The plus or minus sign means there can be two solutions, one solution, or no real solutions depending on the value inside the square root, called the discriminant. If the discriminant is positive, the quadratic has two different roots, so the parabola crosses the x-axis twice. If the discriminant is 0, there is only one root, and the parabola just touches the x-axis at one point. If the discriminant is negative, there are no real roots, meaning the parabola does not cross the x-axis at all. This is why roots appear as x-intercepts. Because they are the exact x values where the quadratic function equals 0, and graphically, that is where the parabola touches or crosses the x-axis. Understanding this connection helps you see how solving the quadratic equation is directly related to graphing the function. When you find the roots, you are pinpointing the exact places where the parabola intersects the x-axis. These points are important in real-world problems too, like figuring out when a ball hits the ground or when a business breaks even. So, in simple terms, the roots are the x values where the quadratic graph touches or crosses the x-axis because those are the points where the function's output is 0. And the quadratic formula is the tool that helps you find those special x values.